So what we want to look at now is the idea of using some new notation for our binomial theorem and representing Pascal's triangle. Now, from what we've done, you can see that we can do Pascal's triangle pretty easily, but it's a little bit tedious. Like, to get to the 10th line, we've got to go through every line. So can we come back to a way of getting this relationship through an easier way? Now, we can. We're using what we call the nCr. It's what we often call a combination, or combinatorics. So the idea of this notation, nCr, is that we're going to have a value of n and then the value of r. Now, the value of n is always going to be greater than the value of r. So basically what we're saying is, like, how many ways can we get r groups out of n groups? So, and we'll use that a lot more when we do probability with combinations. But that's basically what I'm doing. How many sets can we get of a particular amount out of the total? So if we have a look, 0C0, if we and set up our notation this way and relate it back to our expansions we've seen before, we can see that 3C0, 3C1, 3C2, 3C3, and we can see that we can use that, and that's the numbers we get. Now, to get any of these numbers, we can use our calculator. So if you go to the second function above, the notation, the multiplication division, so then you have what we have, nCr and nPr. Now we're going to use P a lot more. We're not going to use it much now, but it's a second function. So have a look for that one, and you can basically put a value in. So if we're putting 43C3 in, put a 4 in, then we push the buttons, and then we put the 3 in there. So we can also see this situation as well, that any value in a term, and this is what this notation, the 4C1 is given to us by the 2 above it. So the m-1, so the line above is the m-1, the n, and the r-1 would be the term before the 1, and then the term of the 1 as well. So you can see that's basically, that notation is basically saying any term here is the sum of the 2 above it. So that's where that notation comes in. So what does it mean for our Pascal's triangle and getting our binomial expressions? So basically, instead of putting our terms from Pascal's triangle in this time, we're just going to use our notation for the combination. So nC0, nC1, nC2, nC3, and that goes through to nCn. So basically, it's n because that's the value there, and the number here comes from whatever value we are putting there for that term. So, and remember, it doesn't really matter whether you have that number to the power of 2 or the power of 3. Remember, because the symmetry that's involved means that it doesn't matter which one's first or second in that term, and the way you set it out, because you'd read it forwards and backwards, it would be the same. And again, if we use x being equal to b on a and multiply both sides by n, basically if we express it in this term, we get the nC0 a to the n, nC1 a to the m-1, and then the b starts to be a power of 1 because it's b to the power of 0 there, and the nC2 a to the power of n-2. So really, what we're saying is the first term would be the subtraction of the difference between those two, and the second term is whatever the value is there, and whatever the r value is if we're going to have nCr as that. So we can write any term in that way. So nCr would equal a to the power of m minus r, b to the power of r. And as I said, it doesn't really matter which way we go around. And if it was b to the power of m minus r and a to the power of r, you could still use the nCr or whatever the symmetry would give us in that one. So that's basically our general term that we come back to all the time. So keep that in mind, because we're going to try and use that as much as possible. What we should note as well is that if we've got n terms, if it's power of n, we're going to have m plus 1 terms. So if it's the power of 10, there's going to be 11 terms. If it's power of 4, it's going to be 5 terms in our expansion. So keep that in mind, that we're going to start with nc0, finish with ncn, so there's n plus, if it's power of n, be n plus 1 terms there. So keep that in mind as we go through and do these ones.